everyone, in this video I will show you how to assess cycling accessibility using PedCatch. To get started, let's search for PedCatch on your browser. Once you navigated to the PedCatch website, let's search for a location in the search bar. For now I search for Swinburne campus as an example. Then the map will navigate you to your locations, and it also highlights the street networks surrounding it for you. You can also change the style of your map in this drop-down menus. You can change it to OpenStreetMap or satellite based on your preference. And this yellow dot right here is your marker. You can use it up to 3 markers. So basically it's the starting point where the pedestrian movement is going to move from, and in this tutorial is the starting point for the cyclist. So now as I want to analyze 10-minute cycling catchment surrounding Swinburne campus, so I'm gonna put it on 3 different entry points to the campus. Now what you need to do before your simulations is making sure your speed is set. Currently the default is 1.33 meters per second, which is the average walking speed of adults. For cyclists it's around 4 to 5 meters per second. I'm gonna set it to 4 meters per second, which is a typical city cycling pace. And for times, it's how long you want them to cycle within your areas. So I'm gonna choose 10 minutes for this video. Then for gradients as well, this is very useful for analysis. The default is 1 to 14, and as you can see, they will be highlighted in darker red areas just like this. You can also turn off the gradient based on your scenario. For pedestrian, many people don't like to walk in an area that is too steep, the same as cyclists. So now I will set it to 1 to 10. This will identify areas where steep slopes slow down cyclists. Then we can select the isochrome type in this drop-down menu. And I'll choose an offset of 50 meters. This will offset the cycling ability of 10 minutes by 50 meters. So you can see how that appears and how that is calculated. Once you set up all the settings, you can now start to run the simulations. This will just take a second. So they started to progress the scenario, and during the process you can see the particles move from the starting markers and progress out for that 10-minute cycling ability. The purple circle outside is the isochrone offset that we set. And then the purple around the edges on the inside of that circle is where 10 minutes marker will stop. For cyclists, their mobility is faster than pedestrians, so overall we see that there's no significant barriers appearing within 10 minutes cycling. For this video in Swinburne campus, the connectivity itself does not have significant issues. The main issue is there's no connected or continuous protected cycling way. In the second scenario, we have to delete all the street that has no protected cycling way. For example, Glenferrie or Berwick Street, which is clearly have no protected cycling path. So right now we have to create that scenario so that we can test the difference. Now the final thing to do is download the KML scenarios as well as GeoJSON. In the next video, I will show you how to delete auto paths using QGIS, and then we can import the scenario back to PedCatch to compare the difference. Thank you for watching.